electric and hybrid vehicle engineering inside hybrid and electric vehicles. In this lesson, we'll study about Introduction to Electric Vehicles, and the topics which we will be covering are Introduction, where we will discuss about the main question, that is what is EV, that is electric vehicle. Then we'll talk about history, where we'll talk about first electric vehicle and about its initial stage. Then electric vehicle component, and at last types of electric vehicle. So what is electric vehicle? Electric vehicle, or EV, which is a short acronym for electric vehicle, it can be defined as a vehicle which is driven by electricity in simple terms, and it functions by plugging into a charge point and taking electricity from the grid, and then the electric vehicle stores that electricity in rechargeable batteries that power an electric motor, which further turns the wheel. It is the same concept that we have while our charging of our phones. They also accelerate faster than vehicles with traditional fuel engines. That is the main reason we feel light while driving those electric cars. And they are also either partially or fully powered on electric vehicles. Now that we have looked over what is electric vehicle, let us have a look at its past history. EV holds a very interesting history. Therefore, early electric cars were also considered an ideal alternative to combustion and steam, which is the current scenario right now. And most of these consumers included women who found they were perfect for short trips around the city and were easy to operate. But ironically, when Ford developed its Model T, that is shown here in this picture, in 1912, it was the first alternative electric vehicle, but it came as a death knell for early electric cars of the time. So as you can see how the downfall of electrical vehicles started, and it was until there was a oil crisis of 1970s. After then, the people realized the importance of electric vehicle and started working over it. There were many researchers, inventors who contributed towards the development of early electric vehicle. But the first successful electric automobile, which was termed as the Electrobat, was developed by mechanical engineer Henry G. Morris and chemist Pedro G. Salem in 1894 in Philadelphia. And after these, many further developments in electric car technology developed, and it was considered as the golden age for that technology to grow. And as a result, interest in electric cars was rising throughout the later 1890s and earlier 20th century. Now coming over to components in electrical vehicle. Electric traction motor. It provides necessary traction to the wheels for motion. Then power electronic controller, which is a necessary item which is responsible for governing all the electric component that is present in our vehicle. Then it comes DC-DC converter, which is necessary because device provides normal vehicle accessories work, power and recharge the auxiliary battery. Then thermal system, which is responsible for maintaining the right optimum temperature for all the electric vehicle components to work in a proper order. Then traction battery pack, which supplies power to electric traction motor for propagation. Then transmission. Then onboard charger, which allows to convert AC electricity to DC power for the traction battery charging. Also, it has control function of main battery characteristics such as voltage, temperature, current and state of charge while charging the pack. Then auxiliary battery. The main purpose of auxiliary battery is providing electricity to power vehicle accessories in an electric vehicle. Then charger port, which is necessary because that allows the vehicle to connect to an external power supply in order to charge the traction battery pack. You can also see the charge port shown at the picture here. So now various question arises, such as why do we require EV in future? And if yes, it is required, then what government is doing to nurture this technology for our future? Let's have a look at it. At a fundamental level, electric cars offer a dramatically lower operating cost compared to conventional internal combustion engine, which make it as more reliable than ICE. This also holds true across various factors because it's materially cheaper to charge a battery compared to refueling a conventionally liquid fuel tank. And adding to this, EVs have 75 to 80% fewer moving components, which led to less vibration losses and lower fatigue life, therefore which ultimately increases its life. And adding to this, it also translates to a much lower maintenance bill. Now looking at what government is doing to promote this technology. In the case of India, the Indian government has already made its move for its goal of making 30% of Indian vehicles electric by 2030. Battery electric vehicle, we can say that they are better for environment, less expensive than gas, needs less maintenance, thus reducing our maintenance cost. They also tend to be quiet, and considering all, the initial investment is quite steep. Now coming over to fuel cell vehicle. Fuel cell electric vehicle also go by the name fuel cell vehicle. They got this name because they are driven by fuel cell that uses chemical reaction to produce electricity. Hydrogen is the fuel for choice for FCVs to carry out this reaction. That is why they are also called as hydrogen fuel cell vehicles. They are more efficient than conventional internal combustion engine vehicle and produce no tailpipe emission. And coming to tailpipe emission, they only emit water vapor and warm air. And if you consider their storage, they carry hydrogen in special high pressure tanks, with and another ingredient for the power generation process is oxygen, which it acquires from the air that is sucked in from the environment while its propagation. It uses a same propulsion system that is similar to that of electric vehicle, where energy stored as hydrogen is converted to electricity with the help of fuel cell. And adding to this, it is similar to conventional IC engine when as they can fuel in less than 5 minutes and have a driving range over 300 miles, which is efficient for highway conditions also. Here is the video from where you can view about how the reaction between S2 and O2 take place, resulting in energy for propagation purpose. As you can see, there are two membranes for S2 and O2, and when they react, they produce energy while the reaction is taking place. Now moving on to hybrid electric vehicle. A hybrid vehicle uses a gasoline engine and electric motor. It can be classified into different categories. The three categories include series hybrid, parallel hybrid, and plug-in hybrid, which is considered as one of the three major types. We'll be discussing about them in further lecture. Thank you. That is all for today.